Hello everyone, welcome to my channel again. We'll discuss about Kubernetes today. What is Kubernetes? What are its use cases, and what are the components are in Kubernetes and how they are stitched together, right? So basically, you can see the building blocks of Kubernetes, right? So the definition as it goes, Kubernetes is an open source platform uh, to manage containerized workloads and services, right? To be very simple, in very simple terms, right? So you can think Kubernetes as a microservice platform or a container platform, right? So there are few things in Kubernetes which make it um, more appealing and appealing towards the uh, go-to tool for containerized workloads. We have Docker Swarm, right? But it scores over that, right? You have self healing. You have intelligent scheduling. You have load balancing, and you most importantly you have a community that supports Kubernetes. So a large community which helps you learn and grow and adapt Kubernetes, right? So that's why it has become a de facto tool for the containerized workloads, right? Saying that, so let me take you through the next slide. So basically, you have to understand, before understanding Kubernetes, you have to understand uh, the uh, the Docker, which runs those containers, right, behind the hood of Kubernetes. So Kubernetes is kind of a wrapper or manager on top of that Docker, right? So in Docker, as you know, you have a server, or you have a infrastructure. On top of that you have a host operating system, then you have Docker on that, and then you have different containers running inside Docker, right? So it's lightweight in nature, and because it doesn't have its full-fledged OS, so it is lightweight, and it can be created rapidly and destroyed rapidly. So kind of a agile in nature. So in these scenarios, like this real world scenarios where you have to create the infrastructure through code, right, rapidly, and destroy them, test and destroy them rapidly through, uh, it comes as a best fit for that. Okay, so if you see in this picture here, over here, as I have described, let me open up the pen here. So if you see, this is containers, right? What from your operating system is believed, right? It's your apps, right? And who is designing that? The Docker engine, right? Engine is talking to the host operating system, and from the host operating system. So while in case of a VM, right, or virtual machines, you have a guest operating system for your VM, and your VMs are sitting on top of a hypervisor here, right? And then they have their own OS, right? Fully grown OS, or fully full-fledged OS, right? And the hypervisor is facilitating those VMs life cycle, right? So you essentially are you essentially are negating this part of this part of the this part of the machine, and you are not running its full-fledged OS on in case of a container system, right? So that is the benefit. So uh, so let me clear these drawings, right? So So let us see the ecosystem, Docker ecosystem, and how Docker works. Right. So basically, you can build images through Docker, and you run containers with that. Right. So these Docker images can be part of some repository. It can be part of your local system, or you can push it to a Docker repository, right? It can be ECR, it can be Docker Hub, right? Anything. So if it is a public repository, you can use Docker Hub, or if you want to private repository, you can use ECR or Nexus, So, mm, uh, so basically, or Artifactory for that matter. Basically, if you let's not get into that right now. That would be confusing. So let's see the basic concept of the Docker, right? So if you see it here, what you are doing is essentially you are having images, right? Let's think this is in your Docker host locally, right? You're saving all these images on your Docker host, right? And using those images you are creating multiple containers, right? And on those containers you have your applications, right? So essentially what we have seen in the slide before, the same thing, and it is just just depicting that what components are broadly used for Docker. So broadly it is Docker host, right? The host operating system, and on top of that you have a Docker engine, or Docker engine is this the Docker engine that is running. This is the Docker daemon, right? And you have a image repository. Either you are saving it in Docker Hub, or you are saving it in locally, these images, and using these images you are creating those containers, and these will be the base images. On top of that you are creating your application, or you are create all of them together. You are creating a image and storing here in the local system, or either you can push it to the registry, right? A public or private registry, right? So let's go to the next page. So basically, as I have said, or been discussing about the Docker concepts, here we will see how Kubernetes, how they are being put into the Kubernetes, right? So basically, in the sense of Kubernetes, you have a pod here, right? A pod, this one, the pod, right? A pod would have a single container, or would have multiple containers. It can have multiple containers, or it can have single container. So basically we use a single pod, single container in general, right? But it can have multiple container inside a pod, and essentially if it is a stateful application, you can have volumes, right, attached to it, or if it is stateless, it is like you don't have to add up physical volume to that, right? And these pods, right, will in the later part of the discussion today we'll be discussing that how these all these components of Kubernetes are being stitched together, right? So let's go to the next page. So mm, so let's get into Kubernetes architecture. right? So if you see it here, we have two things in Kubernetes architecture broadly: a controller node or the master node, and then you have worker nodes, right? So the controller node is managing, or is responsible for managing the worker nodes, and how it manages the worker nodes is managing through the kubelet service, right? So essentially, if you see on the right side of my presentation, you can see that you can see I have a let me just pick up this pane where it is. Okay, okay. If you see to the right of my presentation, I have master node here, right, or the controller node here, and I have couple of worker nodes here, right. So in the worker node, the pods will be placed, right. There would be pods related to Kubernetes control plane inside master node, and uh, we can also place workloads to master node if it is not tented, or if we have removed the tent. It can be placed, but by in general we do not place anything apart from the queue system related or control plane related pods, right. So every workload, app related, application related workload goes to the worker nodes. So as you see, every worker node is having a kubelet domain running, right. And uh, they have the pods, and inside the pods they have the containers running, right. And essentially these worker nodes will have docker also running, because the docker is base of our running of our uh, pods or the containers, right. So docker should be running, kubelet should be running, and then comes the kube proxy, which uh, give your application a way to communicate to outside of Kubernetes network, right. So key proxy controls that. So if you see, you have the control manager in master node, which is responsible for service accounts, replications, namespace, and you have the scheduler, which is responsible for um, scheduling the workloads to worker nodes, check worker nodes capacity, and decide intelligently that which workload should go to which worker node, right. And then you have the etcd here, which will have the metadata for all your Kubernetes cluster, which should be placed in your master node, right. So so to manage all this, we use kubectl, right. And kubectl essentially talk to the Kubernetes API server, right. So we communicate through Kubernetes API server, and do all our place all our resources, delete or do a CRUD operation of any Kubernetes resources. All right. So let's go to the next page. So essentially what, let me clear up this markings. So essentially what you have seen over here is what you have seen over here is the things that we just discussed about the control plane, what it is having, right. So you can say recommended practice, not run application workloads on master nodes, right. And the data plane is nothing but your worker nodes, right. And kube proxies manipulates routing to redirect traffic to the target pods. So basically you can say that the proxy to proxy of the network traffic, right. So let's go ahead. So if you see, essentially this is the high availability of cluster. So basically what we wanted to say over here is that uh, the Kubernetes master is we have three master node placed across uh, three different zones, right? Availability zones, and if any of them fails, there are other two which can take care of, and also the worker nodes are placed accordingly to different availability zones. Okay, so let me just stop this PowerPoint. I would bring up some images about different components that Kubernetes is having, and then we'll discuss how they are correlated with each other. Let me clear up the drawings, close it up, and so as we have discussed before this also, uh, like we have a control plane which is having etcd, control manager, scheduler, and API server, and then you have worker nodes where kubelet is running, kubeproxy is running, and you have the container runtime or the pods running over here. And if you want to if you want to contact those pods, you will have essentially the services, and those services would be connected through the end user would be connecting those services through a load balancer, right? So there are different types of services. We'll talk that in detail in service section. So let me change to a mouse. Let me see. So essentially a detailed diagram of how things are there on the Kubernetes control plane, right? You have the kubelet running over here. Then you have you have the container runtime, etcd, API server, kube proxy, scheduler, kube control manager, cloud control manager if it is a cloud node, right? So all these things forms your Kubernetes master, right, or the control plane. So let me okay. So let me take you to the node as we have completed about control plane, and now comes the node. In the node section, if you see it, we have in the node section, if you see it, we have this worker node. We have containers, right? Inside that, you have a container runtime, you have kube proxy, and you have kubelet daemon running on a node, right? So let's go to the mainest part of the Kubernetes architecture, that is a pod, right? Inside a pod, you have the container here inside a pod, right? So as I've said in the beginning, that we can have single container or we can have multiple container, right? And then if you have a stateful application, you want a external volume, you can add that to a container, and this container will be connected to a pod network, so that this container could be having a IP, right? Every container would have some IP, and that IP would be in turn managed, would be in turn contacted by the services that we'll see in the next diagram, right? So here comes the service discovery, right? So essentially what we are doing is essentially what we are doing is uh, If you see it over here, let me just try to place it correctly. Yeah. So if you see, this is host A or worker node A and worker node B, right? And every pod here would have some labels, right? And the service you create, you are giving labels to the uh, service, so that in their manifest, so that using that labels, they would make sure that they are contacting the right pods, right? So essentially, what you have now, you have service, like if I sorry, if I go in the top down approach, so you have service, uh, you have a pod, right? Or con- or container, right? Or then you have a node, right? Then you have control plane, right? So okay, so let's go to the next image, where it is about the persistent volume and volume claim. So what we are doing essentially here is, we are attaching a volume for a stateful workload to have a storage, or have a disk to store the data, right? Like if you have a database, or if you have an application which need a stateful which is stateful in nature, so that you can add a physical disk to the Kubernetes cluster, and then you can use the PVC, or the persistent volume, to attach that the physical volume or persistent volume to that persistent volume claim, and then the pod would be referring to that persistent volume claim with a claim name here. If you see it here, if it is a claim name given here, which would be referring, right? So any application in this pod would be writing to this PV as given by the manifest, right? So uh, okay, so saying that, so this is all about the basics of Kubernetes, how Kubernetes works. If you have any questions, you can put that in the comment section. And if you like this content, please do not forget to share. Please do like and subscribe and hit the bell icon to get more such videos on Kubernetes series. Thank you.